unbelievable electrical discovery in-house. Despite witnessing numerous peculiar electrical issues in their careers, many homeowners may find the following discovery hard to believe. Upon purchasing their rental home and having an old hot water tank removed, an unusual receptacle was uncovered. It was a two-prong outlet. There was no cover plate. The upper half of the outlet was cracked. The lower half had a three-prong plug connected via a cheater adapter. The white wire insulation was missing for 1 inch near the plug. 12-2 non-metallic sheath cable with ground wire was used for the cord. The cord dangled in open air and ran into a gap in the ceiling. Incredibly, unplugging this makeshift connection resulted in the loss of power to 2 overhead lights in the newly added section of the house. The inaccessible location of the affected lighting above the ceiling poses a significant challenge for the contractor tasked with resolving this bizarre electrical problem. When dealing with electrical systems, safety is paramount. Always energize the circuit before working on any electrical components. This can be achieved by switching off the corresponding circuit breaker in the electrical panel. Verify that the circuit is indeed de-energized using a non-contact voltage tester or a multimeter. Never assume that a circuit is off just because the switch is in the off position. Electrical work should ideally be performed by qualified and licensed electricians. They have the knowledge, skills, and experience to handle electrical systems safely and effectively. If you are not comfortable working with electricity, it is always best to call a professional. Using the correct wiring methods is crucial for electrical safety and code compliance. Non-metallic sheath cable, commonly known as Romex, is typically used for residential wiring. It consists of 2 or more insulated conductors and a bare or insulated ground wire, all encased in a plastic jacket. The size of the wire, such as 12-2, indicates the gauge of the conductors and the number of current-carrying conductors. In this case, 12-2 means that there are 2 12-gauge conductors plus a ground wire. Always use the appropriate size wire for the intended application to prevent overheating and potential fire hazards. Ensure that all electrical connections are properly made and secured. Loose connections can cause arcing, which can lead to fires. Use wire connectors, such as wire nuts, to join wires together. Make sure that the connectors are properly sized for the number and gauge of the wires being joined. Wrap electrical tape around the wire nuts to provide additional insulation and secure the connection. When installing electrical outlets, use the correct type of outlet for the application. In most residential applications, 15 amp or 20 amp 125 volts outlets are used. Branded outlets have 3 prongs, providing a path for fault current to flow back to the source, reducing the risk of electric shock. Always connect the ground wire to the green ground terminal on the outlet. Replace any broken or damaged electrical components immediately. Cracked or broken outlets, switches, or cover plates can expose live electrical parts, creating a safety hazard. If you find any damaged components, turn off the power to the circuit and replace them with new ones. Ensure that all the electrical boxes are properly covered. Open electrical boxes can expose live wires and create a shock hazard. Use cover plates to close off electrical boxes and prevent accidental contact with live parts. Avoid overloading electrical circuits. Each circuit is designed to handle a specific amount of current. Overloading a circuit can cause the circuit breaker to trip, or in severe cases, it can lead to overheating and fires. Do not plug too many devices into a single outlet or extension cord. Use a circuit breaker finder to identify the circuit breaker that controls a particular outlet or fixture. This can be useful when troubleshooting electrical problems or when you need to turn off the power to a specific circuit. Follow the National Electrical Code, or NEC, guidelines. The NEC is a comprehensive set of standards for electrical installations. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. Adhering to the NEC ensures that electrical installations are safe and code compliant. When working on electrical projects, always obtain the necessary permits and inspections. This ensures that the work is done safely and in accordance with local regulations. Electrical inspectors can identify potential hazards and ensure that the installation meets code requirements. Regularly inspect your electrical system for any signs of damage or wear. Look for cracked or broken outlets, loose wires, and other potential hazards. If you find any problems, have them repaired by a qualified electrician. Install ground fault circuit interrupter, or GFCI, outlets in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor areas. GFCI outlets are designed to detect ground faults and quickly shut off the power, preventing electric shock. Use arc fault circuit interrupter, or SI breakers in your electrical panel. SI breakers are designed to detect arc faults, which are a common cause of electrical fires. They can help to protect your home from fire hazards. Install smoke detectors and carbon monoxide detectors in your home. These detectors can provide early warning of a fire or carbon monoxide leak, giving you time to escape and call for help. Test your smoke detectors and carbon monoxide detectors regularly to ensure that they are working properly. Have your electrical system inspected by a qualified electrician every few years. This can help to identify potential problems before they become serious hazards. An electrician can also perform routine maintenance, such as tightening connections and checking for worn wiring. Use surge protectors to protect your electronic devices from power surges. Power surges can damage or destroy sensitive electronic equipment. Surge protectors can help to absorb excess voltage and prevent damage. Avoid running extension cords across walkways or under rugs. Extension cords can be a tripping hazard and can also overheat if they are covered. If you need to run an extension cord, use a heavy-duty cord and make sure that it is not a tripping hazard. Keep electrical cords away from water. Water is a conductor of electricity, and contact with water can create a shock hazard. Do not use electrical appliances near water, and do not touch electrical cords with wet hands. Teach children about electrical safety. Children should be taught not to play with electrical outlets, cords, or appliances. They should also be taught what to do in case of an electrical emergency. Be aware of the location of underground utilities before digging. Contact your local utility companies to locate underground utilities before you start any digging project. This can help to prevent damage to underground cables and pipelines. If you smell gas, evacuate the area immediately and call the gas company. A gas leak can be a fire or explosion hazard. Do not try to find the source of the leak yourself. If you see a downed power line, stay away from it and call the power company. Downed power lines can be extremely dangerous. Do not touch the power line or anything that is in contact with it. If someone is being shocked, do not touch them. Use a non-conductive object, such as a wooden broom handle, to push them away from the source of the electricity. Call for emergency assistance immediately. Regular electrical maintenance is essential for ensuring the safety and reliability of your electrical system. Inspect your electrical panel for any signs of corrosion or damage. Check the circuit breakers to make sure that they are properly labeled and that they are not tripping frequently. Tighten any loose connections in the electrical panel. Inspect your wiring for any signs of damage or wear. Look for cracked or brittle insulation, loose connections, and other potential hazards. Replace any damaged wiring immediately. Inspect your outlets and switches for any signs of damage or wear. Replace any cracked or broken outlets or switches. Test your ground fault circuit interrupter, or GFCI, outlets regularly to make sure that they are working properly. Press the test button on the outlet. The outlet should trip and the power should go off. If the outlet does not trip, it needs to be replaced. Have your electrical system inspected by a qualified electrician every few years. This can help to identify potential problems before they become serious hazards. An electrician can also perform routine maintenance, such as tightening connections and checking for worn wiring. When troubleshooting electrical problems, start by checking the simplest things first. Make sure that the circuit breaker is not tripped. Check the outlet to make sure that it is working. If the problem persists, you may need to call a qualified electrician. Use a multimeter to test for voltage and current. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. It can be used to troubleshoot a variety of electrical problems. Follow the manufacturer's instructions when using a multimeter. Be careful when working with electricity. Electricity can be dangerous, and it is important to take precautions to avoid electric shock. Always de-energize the circuit before working on any electrical components. Use insulated tools. Wear rubber gloves and safety glasses. If you are not comfortable working with electricity, it is always best to call a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical safety. Adhering to the NEC ensures that electrical installations are safe and code compliant. The NEC is updated every 3 years. A latest edition of the NEC is available from the National Fire Protection Association, or NFPA. The NEC is a complex document, and it can be difficult to understand. If you have any questions about the NEC, consult with a qualified electrician. Grounding is an important safety feature in electrical systems. It provides a path for fault current to flow back to the source, reducing the risk of electric shock. All electrical outlets, switches, and appliances should be properly grounded. The grounding system should be inspected regularly to ensure that it is working properly. Overcurrent protection is another important safety feature in electrical systems. It protects against overloads and short circuits. Circuit breakers and fuses are used to provide overcurrent protection. Circuit breakers and fuses should be properly sized for the circuits that they protect. They should be inspected regularly to ensure that they are working properly. Wiring methods are the techniques used to install electrical wiring. The NEC specifies the approved wiring methods for different types of installations. Wiring methods should be followed carefully to ensure that the installation is safe and code compliant. Electrical safety is everyone's responsibility. By following these safety tips, you can help to prevent electrical accidents and injuries. Always be aware of the potential hazards of electricity and take precautions to protect yourself and others. When in doubt, consult with a qualified electrician. The homeowner discovered an unusual receptacle. Firstly, the outlet was a two-prong outlet. Secondly, there was no cover plate. Thirdly, the upper half of the outlet was cracked. The lower half had a three-prong plug connected via cheater adapter. Fourthly, the white wire insulation was missing for 1 inch near the plug. Fifthly, 12-2 non-metallic sheath cable with ground wire was used for the cord. Lastly, the cord dangled in open air and ran into a gap in the ceiling.